Hello everybody, this is L. Nagarajan working as an assistant professor in MAM School of Engineering, aggregated by NAC, approved by AICT New Delhi, affiliated to Anna University Chennai. So in today's class we are going to discuss about the flame photometer. Okay. So what is this flame photometer? The flame that we are obtaining by burning the materials, okay, organic or inorganic materials, then that flame is utilized to identify which component is present in that substance which is being allowed to burn. Okay, so that is called as flame photometer. So once again I'm repeating, whatever the question is asked, the answer will be given as a hint in the question itself. So please, here the answer is flame. Okay, here the answer is flame. So in this we are using flame as an operating medium, and we will be identifying the components. Okay, what are the components that we are studying in this medical bio basis of biomedical instrumentation? Usually you will be studying the calcium, potassium, chloride. Okay, so from the beginning we are studying only this. Okay, in the first unit itself we studied potassium and sodium and chloride. Okay, very important topic also we studied, that is sodium pump. Okay, so similarly here also we are going to study the same components, presence of the same components in the system, that is in the solution, by burning that solution. Okay, come let us go into the topic and we will discuss in detail. Yes, flame photometer. It is used to determine the concentration of potassium, sodium, calcium, okay, and also lithium. Okay, so these are the major compositions, that are major things that we are going to find out in this flame photometer. Okay, so it is used to analyze. It is used to analyze the content of these materials. What is this material? Potassium, sodium, chloride in blood. Okay, in blood or urine. Okay, in blood or urine. That is why we will be going and giving the blood samples and urine samples for the measurement of this content. If any of the thing is more or less, then that indicates the deficiency of that material. Okay, if it is low, then here very important thing, even though we are going to identify these chemical compositions in our blood, and this system has to be calibrated, okay, before going to measure the samples. So how it can be calibrated? It is calibrated by using lithium salt. Okay, by using lithium salt. So we can add this lithium salt and make the system to calibrate that it should glow. Keep in mind, it should glow properly when the lithium is added. Okay, when the lithium is added, it should glow properly in red color. Okay, it should glow properly in red color. There should not be any color content in that in that flame. If there is any color content apart from red color, then it means that the system has to be cleaned, and again we have to add the lithium salt and we have to perform the calibration. Okay, next, what about the color of the remaining substances? Okay, we found out that lithium will burn in red color. And what about the color of the lithium, sorry, that sodium and potassium? Okay, sodium will glow in yellow color, and potassium will glow in violet color. Okay, sodium will glow in yellow color and potassium in violet color. How we can keep in mind the sodium is in yellow color? Very simple. In highways, you will be finding yellow color lights. Okay, you will be finding yellow color lights, very big yellow color lights, street lights. Okay, in highways and in some junctions also. Junctions in the sense road meetings. There is when three roads are joining in a point, that is a junction, and four roads are joining in a point, that is a junction, and uh, very high densely populated areas such as the shopping malls and such as the bus stands, that is junctions, bus junctions, railway junctions. Okay, wherever the light is required. Okay, this is an diffusion form of light. Okay, so wherever the light is required, if the light glows in yellow color, then blindly we can say that that is an sodium bulb. Okay, sodium bulb will glow only in yellow color. So that is why sodium it glows in yellow color and potassium in violet color. So this is the characteristics of the sodium and potassium when it is allowed to burn. Okay, in this method, fine droplets of the samples is aspired into a flame. Okay, that burns in a chimney. Okay, so chimney is an arrangement that is a burning arrangement. Okay, then a known amount of salt is added for the sample as a reference, and as a result, red is emitted by lithium and yellow, violet are also emitted due to the sodium and potassium. Okay, and these diffracted lights are made to incident on the photodiode. Okay, there will be three photodiode. Each photodiode will conduct only when there is in presence of their defined wavelength. Okay, defined color. So when there is an red color, then that red color defined diode will starts conducting, and when there is an yellow color, then yellow color diode will starts conducting, and when there is an violet color, that violet color diode will start conducting. Okay, and the amount of color, the amount of conduction. Okay, if there is more amount of color, then diode will be entirely resistive free. Okay, and if there is very less, then proportionally to that light, it will do its conduction performance. Okay, right. Next we will go to look at the apparatus. Okay, this is the sample solution and this is the burning chimney. This is the air inlets. Okay, and fuel is also there. This is the burning flame, and again this flame is let into a slit. Slit is a very small opening where the light is focused into a narrow beam. Okay, and here is a diffraction grater. Okay, and that light is diffracted into three diode. Okay, so this is a red beam lithium detector, this is yellow beam sodium detector, and this is a violet beam potassium detector. Okay, and if there is any detection of lithium, this will starts conducting, and the proportional amount of current will pass through this uh, amplifier. Okay, similarly for yellow, similarly for violet, and these connections are given to the identification of sodium and potassium, because lithium we no need to find, because lithium is the reference. Okay, next we will go for the analysis. So again the calibration is done by this lithium salt and this waveform. Okay, this is an waveform of to finding the amount of ions present in that calcium, so that is sodium and potassium. calcium, sodium, potassium. And let me show the color of this light. So if you look at this, you can able to understand how the flame photometer is working. See, this is the sodium. When sodium is added, the light of the color is yellow, and when potassium added, the light of the color is violet, and when lithium is added, the light of the color is red. Okay, so now you might come to a conclusion and understand that flame photometer. And in the next class, we will discuss about the spectrophotometer. Okay, fine. Thank you.